All right, guys, a quick blurb about metals and why they're so special. Please take notes as you go along if you wish to. You will be responsible for this on the test. Metals are really unique and special, and the reason why is they're electrons. Okay, if we take a look at where metals are, for the most part, and I know it's not just here, but a lot of the main metals that we talk about are transition metals. We're talking about iron and copper and gold and silver. Their highest energy level does not contain many electrons. And what are we talking about here then? We are talking about the d orbital. That's the biggest deal that we can talk about here. The d orbitals do not have a lot of open or a lot of full electrons, so there's a lot of open space. Because of that, the vacant overlapping orbitals allow for electron movement. So what it looks like is this. All right, each circle with a positive in it is a nucleus. So one atom is on to the next. Okay, what this allows and what this shows is that because of this open vacant orbital, it allows for electron movement that we call free roaming electrons, or a lot of people refer to as a sea of electrons. You have this ability of electrons to be moving in multiple varying different directions. By having the ability to have different directions, it allows it to be able to be bent and be malleable in different ways, and we'll talk about those all in a minute. But think about it, if you bend a stick or a piece of plastic, usually it's very rigid and it'll snap, and sometimes it snaps in one direction versus another. Metals really don't do that. Metals can be manipulated in almost any direction. It's because the electrons are moving in all sorts of different directions, which does not allow a weakness potentially. So let's talk about that. There are some different terms. One of them is conductivity. What is conductivity? It's the ability to conduct or hold heat or electricity. Why does this occur in metals and not other compounds? It's from the freedom of electrons to move around. When electricity is the movement of electrons. Keep that in mind. Electricity, wow. That's great. There you go. Easy for me to type, right? So if you have the ability to move around, it's going to carry that current. If electrons are flowing freely in the sea of electrons, why can't you have a greater ability to conduct electricity and heat for that matter? What metals also do for us is it can be malleable and ductile. Malleability is the ability to compress. It's technically to press into a sheet, but that is like when a pirate is bending gold in their mouths to see if the coin is real. Although not a pirate, gives you a good visual. Checks for the authenticity. If it bends, then it was pure gold. Ductility is the ability to pull a piece of metal into a wire. So what would be a good example of that? Copper wire, right? The best wire that we usually have at the price that it is at. So ductility is to be able to draw a metal into a wire. Either one is able to be stretched, manipulated, pressed, pulled. The reason why is that the bonding is the same in every direction. One layer can slide past another without friction. Well, there are different kinds of metals. Some are weak, some are strong. But what mankind has done is they have created alloys. And alloys are a mixture of solutions of metals. Okay, and there's all sorts of kinds of alloys. Here's a list of some of them. Please don't write this down, but you'll see some more important ones than others that we have. Brass is a big one. That's copper and zinc, a little bit of lead. Bronze, copper, and tin, besides other things. Pewter, it's tin, copper, antimony, bismuth. You got white gold. You have steel, which is iron and carbon mainly. Sterling silver. I mean, the list goes on and on. What alloys do is it maximizes the positives and minimizes the negatives. So for example, a great example is steel. Steel, iron is very brittle, but you pack it in with some carbon and all of a sudden now you have a really strong substance. So when we take a look at alloys, there are two kinds, and you need to know these two names, okay? And I'm asking you to recognize it if it comes into play. It's substitutional and interstitial. Substitutional is just how it sounds, something is substituted. So if something goes in, something else has to go out. Interstitial is literally in between the spaces. So metal replaced with other metals is substitutional, and it's usually of similar sizes, because if you take something out, you got to put something else back in. Interstitial, there's extra openings and atoms can be placed in there. So here's two examples. Brass. You take out the zinc or the copper and you put in zinc, and you have a combination of copper and zinc, and you make brass. And they're all basically the same size. Steel, you already have the iron, and what they do is they place that carbon in between the iron atoms, and it causes it to become much stronger and changes the whole dynamic of the metal. And that's what an alloy will do. For example, 14-karat gold. Gold is so malleable that if you had pure gold on your watch or your necklace or your ring, by the end of the day, it may not even be on your person any longer, because it would be so beat up and bent and dented. So you have to make an alloy. So those are some metals, information on metals. Please make sure that you have this information down, and we will talk about more of it in the next upcoming classes.